I wanted to make a video here to explain to you how our homeworks are going to be working for the rest of the semester. So instead of our regular homework assignment, although it's still a homework assignment, I'm going to refer to them now as workbooks. And you're going to have one workbook each week. And the idea is that if you work through these workbooks, it's essentially like all the content that you would get if we were in class today together. Not quite the same amount of content. It's actually pared back quite a bit, but a lot of the important information that we need to know. And I'm going to post videos within this workbook. And the idea is that if you read or watch those videos and do the homework assignment, then you'll be working through the important content that we need to get through this semester. Okay, so the workbooks will be assigned on Mondays. They'll be due at the end of the week on Friday at 5 p.m. So look at them early, start on them early. And if you have questions about them, you've got to get in contact with me through Zoom or send me an email or a message in Canvas, and then we'll schedule a time to meet to chat about some of these problems. It's going to be a little bit different now because we are doing this all online and you're used to seeing me working through problems in class. You still need to see me work through problems. We still need to have that same experience, but it's not easy for me to do that in a normal Zoom meeting because I'd be sitting at my computer and there's no way for me to really get a good angle to see work on a large chalkboard. So I have to record a bunch of these videos in advance of me working through problems, and I have to post them. And you get to walk through them and sort of these little mini chunks that I'm calling mini lectures in order to help you solve some of these problems. Okay, so let's take a look at what one of these workbooks looks like. So here's one, week 10 workbook, which I will post here before I go to bed tonight or early Monday morning. And there's 10 points. This is all going to your homework score, and I've embedded some videos inside them here. So this first one is information that we learned last semester. So our first problem, or not last semester, before we last met before spring break. So this first problem is about a circuit composed of 3 capacitors. 2 of them are in parallel, and those 2 in parallel are in series with the third one here. And here is a video where I work through how to solve a problem very similar to this. You'll read that video and then work through it and then put your answer right here. Okay, find the capacitor, find the charge on capacitor C2. And I tell you what all the different capacitances of these different capacitors are, and you'll report your answer down here in units of microcoulombs, okay? So that's a standard homework type question. Now, there's a new component to some of these problems, and there's a new component to this first one in particular. And so let me read this here. Our next 2 exams, exams 3 and 4, will be administered online. There's no way around that. In order to receive partial credit for these problems, you need to demonstrate to me that you understand the problem-solving process, because I'm not going to be able to see your work written down on a piece of paper anymore. But I still want to give you partial credit. So, as such, you'll need to explain to me in words the methods used to solve the problems and which equations you used, okay? We will be practicing how to do this within each assignment from now on. I've got 2 examples of that inside this assignment. This is the first example. So the point breakdown for each of our exam problems will be pretty much the same. You'll get 3 points for indicating the appropriate equations or relationships used to solve the problem. You'll get 4 points for explaining in words how you solved the problem using appropriate methods. You need correct grammar and complete sentences, if appropriate. And then you get 3 points for the correct answer. The answer part will be graded automatically by Canvas, And I'll give you 2 attempts on your exams, the next 2 exams in the future, to get it right. Each time you try again, of course, all the values will refresh and you'll have to type in again your free responses. So keep that in mind. So in the space below, we are going to practice doing this for this homework problem above, or this workbook problem above. Okay, so you'll see the reason why I'm doing this here, so you get practice with it, because this is what we're going to be doing for future exams from now on, okay? So in this space below, discuss both the equations you use to solve this problem above and your problem-solving process, how you solve this problem in words. So this is going to test a different part of your understanding of physics versus what we did before, where you wrote down all of your work and you presented it to me on paper in the exam. Now you have to do it in your own words. Maybe that's a little bit harder in some ways than actually showing all of your work, okay? So I'll be reviewing these and providing comments, so be sure to check your feedback on your homework, okay? Check your feedback. In particular, if you, especially if you don't get full points for this, you'll want to see what you missed. Okay, so, but within our workbook, doing this is only worth 1 point. They might give you partial credit for there too. All right, so I'm going to show you how we're going to do this. I'll give you an example. So you will have watched that video of me working through how to do the above problem, okay? And then you yourself, when you're working through this workbook, you will have to answer this question here, where you are going to have to talk about the equations that you use to solve that above problem and the problem-solving process. Okay, so here's an example of how I'm going to do this. Now, this is not going to make a whole lot of sense to you unless you watched that video already, but so we're going to input our answers for this in this format. We're going to say equations used. Okay, so if you looked at the above problem, you will see which equations we needed to use in order to solve that problem. In particular, we're going to have to use, let me look back at my notes, we're going to have to use the equation for the charge on a capacitor, which Q was equal to the capacitance times the potential difference on the capacitor plates. We're also going to have to use to solve this problem the equations for capacitors in series and parallel. So maybe I'll put these on separate lines here. Enter equations for capacitors in parallel, so that the total capacitance was equal to C1 plus C2, okay? So the total capacitance for capacitors in parallel, we sum them up. Now, equations for capacitors in series. Capacitors in series are a little bit more complicated. Remember that 1 over the total capacitance is equal to 1 over capacitance 1 plus 1 over capacitance 2. Now, there's a really nifty thing here in Canvas if you haven't seen it before. See this little thing where it says insert math equation here? It has the square root and x. I'm going to click on that, okay? And it's going to bring up this new window. Okay, and I'm going to input an equation here for our equivalent capacitance for capacitors in series. And so I'm going to, this button here, N over M here, gives me a fraction. So I'm going to say 1 over, oh, I messed that up, 1 over, down here, C total equals fraction 1 over C1 plus 1 over C2. So you can play around with this and you can make your equations look really fancy, kind of like how I have done sometimes inside our Canvas shells. I'm going to say insert equation. There we go. So now I have that other equation. let's see, what other equations did I needed to use? Equation for capacitors in parallel, I needed to know that Q total, the total charge for capacitors in parallel, is the sum Q1 plus Q2. I also, oh, that was it for that one. And then for capacitors in series, another equation I needed to know is that the total voltage on capacitors in series is equal to the sum of their voltages. So I could say that, okay? So I think that's it for my equations that I needed to solve, to solve this problem. To be sure that you can get them down here like this, just basically look back through all the work that you did and write any new equation that you've used. So you don't need to show me how you've solved these equations for a particular quantity, but you need to start with the initial or original equations, and then just so that I can see that you know where you're starting from, okay? And then now I'm gonna write all the stuff about our problem solving process, okay? So maybe I'm going to bold these. You guys can do whatever you want on your side to make this make more sense to me if you want to do that. So now for my problem solving process, I think when I'm going through problems, I think about my problems in chunks or steps. So however you want to write here, your problem solving process is fine with me, but this is what I'm going to do. I'm going to say step 1 for solving this above problem. What I needed to do first was find the equivalent capacitance of the capacitor combination. Now, for the sake of time, I skipped the part where I typed in all of my stuff under the problem solving process. I realized I wanted to go back when it says equations used. Not necessarily equations, but when I'm thinking about what I need for capacitors in parallel, I also recall that the voltage across parallels and capacitors in parallel is the same. And when I think about my capacitors in series, that the charge on all of my capacitors in series must be the same. Now, when I think about my problem solving process, I usually solve or think about how I solve problems in chunks, or what I call steps here. So this is how I've done it. It's not how you have to do it, but here's one way that I would answer this part where I talk about my problem solving process. So here, I'll walk through it here, and if you watch the video, you'll see that these steps align with what I'm doing in the video. I'm going to find the equivalent capacitance of my capacitor combination. I found the equivalent capacitance for the two capacitors in parallel, which I will call C12. Then using that value, I found the equivalent capacitance of C12 and C3, which are in series with each other. I used the equivalent capacitance of the full capacitor combination to find the charge on the equivalent capacitor. Then I noted that the charge on C3 must be the same as the charge on the equivalent capacitor, since the charge on all capacitors in series is the same. So using this, I then found the voltage across C3 with the equation. Voltage is equal to, voltage across V3, or C3 is equal to the equivalent charge divided by the capacitance of capacitor 3. Then for step 3, the equivalent capacitor C12 is in series with C3. The voltage across them must sum together. So V total is equal to the voltage across the capacitor combination of capacitor 1, 2, capacitor 1 and capacitor 2, plus the voltage across my third capacitor, capacitor 3. And we should note that the total potential difference, the total voltage in my circuit is 12 volts. That's the voltage that's being supplied by the power source. So using V3 from above, I can find the voltage across the equivalent capacitor C12. So if V3 turned out to be 8 volts, total voltage is 12, then the voltage across my combination of capacitor 1 and 2 must be 4 volts because 8 plus 4 is 12. Now, since capacitors C1 and C2 are in parallel with each other, they have the same voltage drop across them. Now, using the voltage for C2 that I found in step 3, I can then find the charge on C2, okay? So maybe it feels a little bit overwhelming, but this is maybe one of the hardest type of problems that you'll have to go through to tell me your problem solving process. So that's why we've gone through this one together, okay? So, you know, I'm not gonna ask for perfection here, but I'm gonna ask that you hit on some important ideas and important steps here that you use as you walk through your problem solving method. So I'm probably gonna be pretty lenient when I grade these since this is a totally new thing for you, but that's why we're practicing it here. Don't copy and paste exactly what I've done here, but you can sort of replicate it on your own in your own words, okay? But I just wanted to go through an example of how to do this with you. And if we scroll down to question 9, here, I'm asking you to do this only one more time for another problem inside this homework set. So this question, how many Christmas tree lights drawing 4.2 watts of power each could be run on a circuit operating at 120 volts and providing 15 amps of current? Round down to the nearest whole bulb, okay? And so here, you're gonna tell me how you solved this problem, and you're going to do it in a similar fashion to how we did it up here, okay? So I'm only asking you to do it twice in this homework set. I might ask you to do it twice or 3 times in our next, well, workbook in order to give you some practice for our exam that we'll be doing. So the exams will be all online. There'll be 6 problems. You'll input a numerical value for an answer. And then after each one, you've got to talk about the equations that you used and your problem solving process. They're going to take you longer than an hour and 15 minutes. They're going to take you, I'm giving you the whole week to work on them, okay? So the numerical answer is only part of the problem. You have to tell me about your problem solving process.